We've seen set, different way we write it, and very good. What are the other things you need to check? The types of sets. I wouldn't really stay too long in this one because that's not really what we need it for, right? Set is a subject for another day. But let's just talk about types of set a little bit, and then we'll now go to the real thing. Now, types of sets. Of course, we know we have an empty set denoted with something like this, or empty curly sign, nothing in it. In fact, let this be known that this set, this one here, is not an empty set, because already you are putting an empty set inside an empty set. It's just like you have a big bowl, there's nothing in it. You don't place a small empty bowl. The bigger bowl is empty, nothing in it. But you don't place a small empty bowl in the bigger bowl, then let's see the carpet, or you leave it away. And someone else say, hey bro, where are you going? Where are you going? You said I'm going somewhere. Once you have it, you have bowl. What's inside the bowl? The bowl is empty. Should I come and find that smaller empty bowl in it? Then you're lying, because it means you are not totally truthful. So if you put an empty set inside an empty set, then the outer set is not empty. Rather, the inner set, the bigger set, the set here, the outward set is not empty, the inside set is empty. And by the way, well, we get to the subject of cardinality, but since this is not the subject of set like that, let's just paraphrase it. And by the way, we now say what? The cardinality. What's the cardinality of the set? The number of elements in the set. The number of elements in the set. So the number of elements in an empty set is what? 0. The cardinality of an empty set. Number of elements, let's say this is set A. Set A equals, so the number of elements in A, which is the same as the cardinality of A, is what? 0. But now, if I put an empty set inside an empty set, the cardinality of this set is 1. Because there is a set in it. You know what I'm saying? There's an element in it. So you wouldn't say that set is empty. Now the next thing we want to go about, at least, okay, an example of an empty set. You can imagine anything. States in Nigeria without governor. Is there a state without governor? Even federal capital territory, there's someone ruling it. But if you now become governor, right, but at least there's someone there ruling. At least every state must have a ruler. You get what I'm saying now? You understand what I'm saying? So in that kind of thing, we say, okay, that is not that state. If you have to generate this states in Nigeria without a ruler, let me not say without governor, without a ruler, that state should be an empty set. Do you understand? So that's empty set. Now another one, we have singleton sets, or we call it unit sets. Singleton or unit set. From the word singleton, what does it mean? Single and then tin. Single element. The T here takes substitute element for it. Single element set. A set with just one element. If God so bless your parents and then someone so love you so much, and then they made an agreement that, oh, it's like, oh, the only thing you want to do is to give it to just the bouncing baby boy, and then let's say you're the baby boy. So the number of the set of children in that family is what? Just one child. It's a 18 set. And you get what I'm saying? At all. You have let's say you have what do you say it now? A packet of biscuits. The packet of biscuits. Although I know inside the packet there are a lot of biscuits. But I say, okay, the set of packet of biscuits. And also the set of biscuits. The set of packet of biscuits, and you have just only one. What is number of elements in that set? 1, bro. So the a singleton set, that kind of set I can say it is what? A singleton or a unit set. A singleton or a unit set. A singleton or a unit set. Now that's okay. Set of governors in a state. Set of governors in a state. I'm not saying a lot of states. I'm not saying Nigeria. I'm not saying US. I'm not saying, you understand. So set of governors in a state. In the first place, it's not governors in a state. You know, it is a governor, right? And the ruler, the governor, the set is just a singleton set because we only have one governor to one state. Do you understand that? That's a singleton set. And then we have, having talked about singleton set, we have equivalent sets. Equivalent sets. And then we now talk about the subject of equal sets too. Equivalent sets. Now, you notice I use the word sets here. I do not say sets because the word this I don't know where to call it. The word and this sentence. This word equivalent is a comparison language. It's a word we use to compare two things. Oh, my age is equal to yours. Oh, that thing is equivalent to that thing. Well, 2.766 is equivalent to 3. So you are using it to compare two things. So an equality to is a sign we use to compare two statements. So if that is true, then I'm comparing two sets. Now, if I have two sets, number one, two non-empty sets. Because once the empty set is empty, there's nothing to which against which I will know what is wrong and what is not. So if I have two non-empty sets, and then we notice that the cardinality, I've told you that the cardinality of a set is the number of elements in that set. We notice that the cardinality of say set A is the same as the cardinality of say set B. Then we say A is equivalent to B. It is not necessarily equal. I did not say it is not always equal. I said it is not necessarily equal. That is, at times, equivalent sets can be equal. And at times, equivalent sets cannot be equal. So we said, if the cardinality, the number of elements, let me give you an example. Let's say we have a set B-O-C-K. I don't know what it means. No. So B-O-C-K, let's say that's set A, and I have a set B, and I say that's R-A-T-E. Now, how many elements do I have there? You are right. 1, 2, 3, 4. So the cardinality of A is 4. How many elements do I have there? Again, you're very correct. Yourself. You say what? That's 1, 2, 3, 4. 4. So the number of elements here, the cardinality of set A and the cardinality of set B, they match. And that makes it what? Equivalent set. So two sets are said to be equivalent if they have the same number of elements or if their cardinality is the same. Now, how about equality? The language of equality is a bit more strict because you discover, okay, look at this set now. It is equivalent, but does equivalence connote? Does equivalence imply equality? Well, not all the time. So I'll say no, since it's not generally yes. Now let's go back to the subject of equality. Now, two sets are said to be equal. Listen. Two sets are said to be equal when the element in the first set is the same element in the second set. I have A in the first set, I have A in the second set. I have K in the first set, I have K in the second set. I have B in the first set, I have B in the second set. Then we say that what? Oh, these two sets are equal. There's nothing in the first set that is not in the second set. There's nothing in the second set that is not in the first set. Are we together here? Are you getting what I'm saying? Now I'll leave you to drop a comment. Let me give you an example before I leave you to drop that comment. Drop a comment on this video and then I'll come back to come and give you the answer. Or in the next video I will answer that. I will give you the answer to that question. Now let's see. Let me see this set A. That set A, I have H-E-A-R-T. Sorry, don't mind me. I said B, I have E-A-R-T-H. This is the set. Now we now say, look at set A and B. H is here, and H is here, good. E is here, good. A here, good. R here, good, and T here. Is there anything in A that is not in B? No. Is there anything in B that is not in A? No. So what do we say? A is equal to B. Now, funny enough, the cardinality of A, 1, 2, 3, 4, 5 elements. The cardinality of B, 1, 2, 3, 4, 5 elements. It turns out that A is both an equal and an equivalent set. So now the assignments. Are all equal sets equivalent? Are all equal sets equivalent sets? Drop a comment in the video, and of course, we do a big shout out to the person that gets the right answer. We do a big shout out to the person that gets the right answer. Universal sets. We're talking about type of sets, universal sets, and then we did not talk about subsets and supersets. Now, what is a universal set? A universal set is a set that contains all the elements in consideration. You understand by consideration? That is, in a given question, all the elements you can never consider, all the elements you can never think of, all the elements that can never come to your mind for that question to be in the universal set. That is, it will be wrong for you to write anything in a given question that is not in the universal set. Are you getting what I'm saying? It is wrong for you to write anything in that question. So far it is that question. Now listen, the universal set of a set may be subset of another set in another question. But in the question they gave you, listen. In the question you are given, the universal set is a set that contains all the elements under consideration for that particular question. So you can now give you different definition. Natural number, set of number from 1 to 10 may be your universal set of states in Nigeria may be your universal set. You understand now? That's very easy. Now subsets of a set. Now the symbols for subset, at times the universal set we use the symbol UE, or some use something like this for universal set. How about subset? Well, when they say something is sub of a set, that is extracted from a set, I can get this thing from another set. That's what makes it a subset of that set. Are you getting what I'm saying at all? Are you following? So when I use the word A is a subset. By the way, this is a sign for subset. This is a sign. Now, if I say A is a subset of B, I mean A is a set contained in B. That is, every element in A is actually in B. All the elements in A is actually where? It's in B. So they will say, oh, A is contained in B, meaning that A is a subset of B. Now listen, just relax. There's something I want you to know. Now, does it mean that if a set is such that the first one contains everything in the other and the other contains everything in the first, do we say they are subset of each other? Yes. Oh, does that make any sense? Yes, my brother and sister. Now, how does it make sense? Now, so far they said subset is a set contained in another set. They did not say that it must be a proper containment or an improper. Don't mind my language. Now, what is the proper containment means proper subset? If A is a proper subset of B, then B will have something at least one element that A did not have. That's when proper subsetism. Again, I repeat. If A is a proper subset of B, then B will have at least one element that A did not have. At least one thing that will make you feel like, yes, I'm your senior. You don't have to talk to me that way. I have some things you don't have. Let me give you an example. And then if it happens that they have the same thing, there's no senior, there's no sense of seniority, there's no sense of junior, then we say that's an improper subset right there. They'll say that's what? Improper subset right there. You get what I'm saying? Improper subset. Okay, how about okay, let me give you an example. Okay, let me explain this and I'll now give you an example of it. Now, supersets, of course, now, if there is a sub, there is a super. If A is contained in B, written this way, then B is the super of A. B is your guy, B is like the boss, B is like the main guy. B is the one controlling A, come here. I'm your senior. And then you don't talk to me that way. Do you get the idea? So if A is a subset of B, and then what will happen to B? What's the relation if I want to reverse it? B is the superset of A. That is, B contains A. B contains A. Now, let's now give you an example and then we'll wrap it up with that. Let's say I have A to be 1, 2, 3, 4, 5, 6. And let's say we have set B to be 3, 2, 4, and 5. Set D to be 6. Oh, let me even use set of LS so that S is less than or equal to 6 and S is a positive integer. And S is a positive integer. Now look at this first set. Look at the elements in A. I want to show now. Now say what's the relationship between A and B. I want to say what's the relationship to the relationship. I will say look at A very well. A has 1, 2, 3, 4, 5, 6. How about B? B has 3 is here. B has 2 is here. B has 4 is here. And B has 5 is here. So that is all the elements in B is actually in A. So when we say B is contained in A. B is contained in A. And better still, you write it as B contained or a subset of A. Now, what's the relationship between B and D? Well, let's see, it's not a big deal. Now, they said this one is written in set builder notation. So set of D is a set of honors. Set of honors such that S is less than or equal to 6, and then S is a positive integer. 0 is not a positive number, it's not a negative number, it's a neutral number. So you know integers can be negative, it can be positive, and it has 0. But there's no fraction, there's no negative, there's no decimal number. Just whole number, positive, negative, and 0. But they said this is a positive integer, and the S will be less than or equal to 6. Meaning that set of X is actually 1, 2, 3, 4, 5, 6. In fact, this one, everything here is T here. Again, B is a subset of D. Now, what's now the relationship between A and D? Now, listen up. Oh, the fact that B is a subset of B does not, and A is a subset of B does not mean that A will necessarily be equal to D. Please note that. Please note that. So don't always assume that since it is like that, it will always be no. Until you write the element and you are able to confirm, or we give you as an assumption, assume. So in mathematics, once you use the word assume, you don't need to bother if it's true or not. It's already said, I should leave it as an assumption. I'll keep the assumption likely. You get what I'm saying? God bless you, bro. So now let me continue. Now there was one lesson about A and D. Well, let's check the elements. 1, 2, 3, 4, 5, 6. And again here, 1, 2, 3, 4, 5, 6. Oh, let's see. They have the same elements. You are right. They have the same elements. But there's nothing in A, there's nothing in D. And there's nothing in D, there's nothing in A. So we say, hey, they are equal, you're right. In fact, I can say A is an improper subset of D. And where D is equally an improper subset of A. In fact, A is actually equal to D. When we go to the series of sets, the set as a series itself, you will enjoy it. Then we go to the mathematical proof. If you want to prove, like there's some theorems in mathematics. If you want to put theorem basically in set as proof, basically maybe with time we'll get to do that. Now, how do we prove? If you want to prove that a right hand side, like I will tell you that A union B or complement is actually A complement intersection B complement. If there's a way you want me to prove this theorem, I will prove it by showing that the left hand side is an improper subset of the right, and I'll show that the right is an improper subset of the left, because you know it is not an improper subset. If two sets are improper subsets of each other, in fact you don't even need to check the two. If A is an improper subset of B, then I know that B will be an improper subset of A. Because what does it mean? Everything that is in A is in B. And then everything that is in B will be in A too. So once you're able to establish that relationship, that one set is an improper subset of the other, this one is an improper subset of this, the two is equal. Do you understand that? So you can then go to the race, play with set and play. Set is very, very lovely. Set is interesting, and I bet there are a lot of things to learn in it.